Hi, this is Mrs. Basin, and today we're going to talk about limiting reactants, which is section 3.7. So a limiting reactant is the reactant that is present in the smallest amount when you have a chemical reaction. So when you have a reaction and you react two or more things together, one of those substances is going to be limiting. What that means is one of them is going to run out first. So you can see the example here where they show you before the reaction, you have H2 and O2 reacting. And like it says here, you have a 7H2 and 10H2 and 7O2. So the H2 are these little white ones, and then the O2 are your red ones. After the reaction, you can see that water is produced. So it makes 10 waters and 2 O2s. After this particular reaction, if you look and see what's left over, you have oxygen left over. So there's still a couple oxygen molecules there. There is no hydrogen left over. So in this case, hydrogen would be the limiting reactant because it's the one that runs out, and then it's also the one that causes the reaction to stop. So once one of the reactant runs out, then the reaction no longer can make products. Okay, and then like we just said, the O2 is the excess reagent because that's what's left over. So the other substance or the other substances that are left, those are called excess. So limiting are the ones that run out. The excess is what's left over. So let's go through a couple example problems. This one says we have part of the SO2 that's introduced into the atmosphere by combustion of sulfur-containing compounds ends up being converted into sulfuric acid. So there's our reaction there. We have SO2 reacting with oxygen and water to make sulfuric acid. Okay, so what I want to find out is how much H2SO4 can be formed if I have 5 moles of SO2, 2 moles of O2, and an unlimited quantity of H2O. So just from the way that is worded, I already know that the H2O is one of my excess reactants. What I have to find out is which of my other ones is limiting and which one is excess. The reason that's important is because the limiting reactant tells us how much product we can make, because it limits how much product we can make because it runs out. So we're going to start with 5 moles of SO2. And the gram to mole conversion there has already been done, so we can go straight to now moles of H2SO4. So that's a 2:2 ratio. So there's 2 moles of H2SO4 for every 2 moles of SO2. Now I can go to grams using my molar mass. So 1 mole of H2SO4 is 98.09 grams of H2SO4. So that's just the molar mass from the periodic table of my H2SO4. So when I do that calculation, if I started with the 5 moles of SO2, I could make 490.45 grams of H2SO4. Okay, then I'm going to do another calculation starting with the other reactant that they gave me an amount for. So this one, I have 2 moles of O2. My mole ratio between O2 and H2SO4 is 1:2. So 2 moles of H2SO4 for every 1 mole of O2. My molar mass for H2SO4 again is still 98.09 to 1 mole. And that gives me 392.36 grams of H2SO4. So when you do these, it's important that you go to the same product. Now this particular reaction only had one, but if you had more than one product, you would want to make sure that you took both of those to the same one. Because now that we have both of these answers here, now we're going to compare. So now what we have to think about is which of these is the correct number. So if I start with my 5 moles of SO2, I can make more H2SO4. If I start with 2 moles of oxygen, I make less. So the one that is less is the actual correct answer. So this one down here tells me that this is how much H2SO4 I can make. The other thing it tells me is that my O2 is my limiting reactant because that's the one that makes less, telling me that that would run out. So that other amount, it's not possible to make. Okay, so let's try another one. This one says we have a reaction below. We have aluminum reacting with chlorine to give us 2AlCl3. A mixture the typo there, of 1.5 moles of Al and 3 moles of Cl2 are allowed to react. What is limiting reactant? And then how many moles of Al3 are formed? Okay, so this one only asks us to go, it gives us the answer, or the reactant in moles, and then it asks us for moles, so this should be a pretty simple one. So we're going to go from 1.5 moles of Al to AlCl3. We're already in moles, and then we're going to actually stop in moles too. So I have 2 moles AlCl3, 2 moles of Al, and that gives me 1.5 moles of AlCl3. And I'm going to do another problem with the other reactant. So the other one says I have 3 moles of Cl2. Same deal, still going to AlCl3. 2 moles AlCl3 for every 3 moles of Cl2. So if I go that route, I can make 2 moles of AlCl3. Okay, so then if I look at those two, again, I'm looking for the one that makes less. So since that first one makes less, this is how much Cl3 I could actually make. That also tells me that my aluminum is my limiting reactant. So chlorine would be excess in that case. Okay, if you need to see one more example, I've got one more here. Okay, this one's going to be a little more complicated because it goes all the way from grams to grams. So this one says we have sodium phosphate reacting with barium nitrate to make barium phosphate and sodium nitrate. So we have 3.5 grams of sodium phosphate, and we're mixing it with 6.4 grams of barium nitrate. We want to know how much barium phosphate can be formed. So just like we did before, we're going to start with our 2 different amounts. So I'm going to start this one with 3.5 grams of Na3PO4. And I'm going to go all the way from grams to moles to grams. And this time I have 2 products. So since it's asking me about barium phosphate, that's the product. I'm going to take both of these 2 because I'm also looking for the answer. I'm not only looking at what's limiting, I'm also trying to find out how many grams of that I could make. So my first step is to go from grams of sodium phosphate to moles. So 1 mole of Na3PO4 is 163.94 grams. Then I can go to my mole ratio. So I'm starting with this. So that's going to be 2 moles of that to 1 mole of the product that I'm going to. And then my last step is to go back to grams of barium phosphate of my product. So 1 mole of that, the molar mass of that is 601.93 grams. So if I do all that, I can make 6.43 grams of barium phosphate. Okay, now with these big problems like this, you have to be really, really careful with your molar mass conversions, because one little mistake in the molar mass conversion is going to throw everything off and possibly have you end up with the wrong limiting reactant, which is going to give you the wrong answer. So be extra careful when you're doing these ones, especially when you're going all the way from grams to grams. Okay, so then the second part of this, I'm going to start with 6.4 grams of barium nitrate. Same deal, but this time take it to the same product. I'm just starting with the other reactant. Convert it to moles. And that's 261.47 grams. Do the mole ratio. I'm still going 1 mole barium phosphate to 3 moles this time because of this. Barium nitrate. And then finally back to grams of that, just like I did the last step up there. That's still 601.93 grams. And that gives me 491 grams of Ba3PO4. Okay, so now I'm going to look at those 2. So I've got, 4.91. So 4.91 grams. So this one up here gives me 6.43 grams. This one down here gives me 4.91 grams. So same deal here. The one that makes less is limiting. So that means barium nitrate is my limiting. And then this answer down here is the correct answer for how many grams of barium phosphate could be produced. Okay, the last thing we want to talk about here is percent yield and theoretical yield. So theoretical yield is the maximum amount of product that you can make when you have a chemical reaction. So it's the amount of product possible as calculated through stoichiometry. So when we're calculating those amounts of product formed, we're calculating the theoretical yield. So that is the maximum amount that you could make. This is different than the actual yield, which is the amount that you actually produce and measure when you make the substance in the lab. So the actual yield number comes from a number off a balance when you actually go and weigh the product that you produced. The percent yield calculates the efficiency of the reaction. So it compares the amount you actually obtained, which is the actual yield, to the amount that was possible to make, which is the theoretical yield. Then you multiply by 100 to get a percent. Okay, so here's an example. It says we have adipic acid. It's used to produce nylon. It gives you the equation there. It says assume you can carry out this reaction with 25 grams of cyclohexane and that is the limiting reactant. So this one they made easy for you because they didn't make you do a limiting reactant first. They told you which one was limiting. So they're telling you that cyclohexane is limiting. And up here it tells me that cyclohexane is the C6H12. So that's my cyclohexane. So I have 25 grams of that. I want to know the theoretical yield of adipic acid. Okay, so to do that, I'm going to do a stoichiometry problem. So I'm going to start with 25 grams of C6H12. I'm going to convert that to moles of C6H12. And the molar mass of that is 84.18 grams. Then I'm going to use the mole ratio between cyclohexane, which is C6H12, and adipic acid, which is this one right here. So the mole ratio between those two is 2 to 2. So 2 moles of H2C6H8O4 for 2 moles of C6H12. And then finally I'm going to go back to grams of the adipic acid. So I'm finding the molar mass of all this. I'm not going to write it all out, but it's 146.16 grams. So that's the molar mass of this substance right here. So when I do that calculation, I get 43.4 grams as my theoretical yield. So that's the calculated value. That's the amount, if the reaction is 100% efficient, that's how much I would actually produce. So theoretical yield, again, is going to be a calculated value. Now they're telling me I ran the reaction and I obtained 33.5 grams of adipic acid. What is the percent yield? So the percent yield, again, is the comparison between the two. So percent yield is actual over theoretical times 100. So the actual, they told me, was 33.5 grams. From the previous slide, my theoretical was 43.4 grams. Multiply that by 100, and that gives me a 77.2% yield, which is pretty good for a reaction.